Okay. Vector. This last part, they will always like to compare the ratio of two areas. Okay? I'm not saying the area will always be in the form of triangle, but usually from the triangle, then you link up to some other parts of the area. Okay? Usually, if they want to compare the relationship between two triangles, there are only two kinds of triangles we are looking at. Okay? There are only two kinds of triangle, and we're going to take a look at the example. Alright, you just have to focus on the slides over here. The first example is this one. I'll write later. Can you tell me what kind of triangles are there?
Similar triangle.
How do you know they are similar triangles?
By A.
Why is it we can use AAA?
Two parallel, the one line across.
Thank you. The most important thing that must be visible must be the pair of parallel lines. The pair of parallel lines. Okay? If you remember, I already did it before. There are only two kinds of triangles we are looking at. It's either the triangle will always look like this. If not, the triangle will look like an hourglass. Am I right? Then, with the proof of AAA. Why is it AAA? I can prove that they are all similar triangle. What kind of angles are these two?
Vertically opposite angle.
How about these two?
Alternate angle.
How about these two?
Alternate angle.
So, have I proven? Okay? Usually, vertically opposite angle, alternate angle. This can be alternate angle. Another reason you can quote will also be, do you remember? Some angles in a triangle. I have two angles in a triangle already. The last one definitely must be equal. Yes.
So if you find two angles, you can just write by A.
My style is 3 steps. Okay, congruent triangle, similar triangle always provide 3 steps. Okay, better, more comprehensive. You still have to use it in the geometry tool for A map. Look at this one. Is there a pair of parallel lines? These two angles are equal. What's the reason? Corresponding. These two are equal. What's the reason? Corresponding. Why is this angle common? It's a shared angle. Okay? Of course, they will not ask you to prove similar triangle. Okay, but now, if I want to compare the area of the similar triangle, how do I do it? What do I need to know?
Find the ratio.
I need to know the ratio of the sides.
Then square.
After that, you need to square it. Agree? We have done all this before. So let's take a look at this one. This side corresponds to this side. If I want to find the area of A1 versus A2, what must I do over here? 3 over 5 squared. So what's the answer? 9 over 25. Should you leave in decimal? Try not to. Leave it in fraction is good enough. Alright? Similarly over here. This is 4. This small portion AY is 1. Can you tell me the area of the smaller triangle versus the big one? What is the ratio? Is it 4, 1? Why 5? It's the whole big triangle, the side ratio. 4 over 5, when you square it, final answer? 16 over 25. This is the easiest form. Similar triangle. All agree? All seen before, right? But how do we know there must be similar triangle? Parallel line. You must be able to see the parallel line. Okay, I've covered the first one already. Very fast. Next. This one. Don't really need, but never mind. Okay, Joey, can you name me 2 similar triangles? Just name me the 2 similar triangles. PSTN, PAB, okay. Is that the only one?
No.
Can someone name me another pair? Yes, something. QST versus QBA. Alright, because these are alternate angles. Okay, you can see? Alright? Reason must be A. The one straightforward. Okay, so I don't have to say too much. Okay, now comes the question. Is PST an equilateral triangle? Can you conclude it's an equilateral triangle? What constitutes an equilateral triangle?
All equal.
All sides are equal. But can we conclude all sides are equal? Take a look. Take a look at the ratio up there first. AB is to FT is 8 is to 5. So if this is 8, this must be 5. Am I right? Same thing. This is a big triangle, this is a small triangle base. So am I right to say this is 5, this whole thing is 8? Agree? Same thing, this is 5, this is 8. But is this the actual measurement?
No, ratio.
This is only the ratio. So can we conclude this equilateral triangle? Cannot. Even though this is 5 units, 5 units, 5 units, but you do not know what is the original length. You only know this is 5 units, this whole thing is 8 units. You cannot conclude it's a equilateral triangle based on units. Okay? This is just for thinking, that's all. Okay, this one I don't do. Okay, now this one. There is a second kind of triangle. First kind of triangle is similar triangle, and we already concluded based on similar triangle. The second kind of triangle is what I call a triangle split into two parts. Can you see there's a triangle split into two parts? Okay? When a triangle is split into two parts, you need to know what is the base ratio. When I talk about a base ratio, can you tell me which one is the base? OB. Can you see that OB must be split into two parts? When it's split into two parts, provided you know how are they being split, then you are able to tell me the respective area. How do we do that? Okay, first thing, you need to know the base ratio. If this is 1, 1, can you see that this is the perpendicular height? All can see? What's the area of a triangle? Half times base times side. What's the other formula for area of a triangle? Half AB sine the angle in between. Okay, but we don't have to use the second one. Let's use the most conventional one. Half times base times side. Regardless, you want this triangle called AON, or you want the triangle on the right hand side, which is ANB. I still use half times base times height. Am I right to say that? Okay, can you see that the height will always be the same? The only thing that differs will be the base. So your half will neutralize. Your height will neutralize. So what you are actually using is just the base. You are just comparing the base unit. So whenever you have a triangle that is split into two halves, you only need to look at the base. That's all. Because based on the area of a triangle, the half will neutralize, the height will always be common. That's it. And you can compare all kinds of triangles. Okay? Just compare the ratio of the base. We're going to take a look at another example. This triangle is given. When this ratio, this kind of ratio is given, it looks difficult. What should we do? Okay, we put all the unknown to one side, we put all the numerical values to one side, then we can see the ratio breakdown. Because if you see BO is 2 times of NO, very difficult. So what I do, I put the NO to this side, okay, and put all the numbers to the other side. You'll see that BO over NO is 2 over 1. BO over NO is 2 over 1 means this must be 2 units, this is 1 unit, so it's 1, 1 itself. Okay? How about this one? Okay, now I need to pull up. Is this a triangle split into two parts?
Yes.
Okay. Okay. When a triangle is split into two parts, what is the most important thing we need to do?
The base.
Base. Are we able to write the base immediately?
No.
Cannot. Then what should we do first?
Move all the unknown.
Move all the unknown to one side. Let's put BO over NO. BO over NO must be equal to 5 over 2. So BO must be 5 units, NO must be 3 units. Since NO is 3 units, can you tell me what is the unit breakdown here? 2. Your guess is as good as mine. If I want to compare the area of this triangle versus the one on the right hand side, what is the ratio? 3:2. But now I rephrase my question. If I want to compare this area called AO, can you tell me what is the ratio? I want this area over here versus the whole area. Even? I want this area that is shaded versus the whole triangle that you see over here. Melissa? How? Area of the shaded one versus this whole area, what is the ratio breakdown? 3/5. Do you need to square it?
Yes.
我要晕倒了. When do we square it? When there is similar triangle. Is this a similar triangle? This is a triangle break portion.
But it is still what this area what?
Precisely. Now let us find the area again.
Wait,
You are not
I
confused.
understand already. I understand. I just realized. I understand.
Let's find this shaded area.
I just understand.
Let's find the area of the whole figure. Do you need to square it? 3/5. Okay, a triangle split into two parts. Just compare the base ratio. We are done. That's it. We are done.